M1 Garand, the rifle that armed a nation. When American soldiers marched into battle during World War II, one weapon defined their firepower, confidence, and battlefield effectiveness: the M1 Garand. Often called the greatest battle rifle of the 20th century by General George S. Patton, the M1 Garand wasn't just a gun. It was a symbol of American industrial might, innovation, and the individual soldier's ability to make a difference on the battlefield. Designed by John Garand in the 1930s, the M1 Garand was a semi-automatic rifle that replaced the slower bolt-action rifles previously issued to American troops. This meant that, unlike older rifles, the Garand could fire 8 rounds in quick succession without manually cycling the bolt, giving American infantrymen a decisive advantage over enemies armed with bolt-action rifles like the German Kar 98K or the Japanese Arisaka. Chambered in .30-06 Springfield, the M1 Garand combined accuracy, range, and stopping power. Soldiers could engage targets effectively up to 500 yards, and with proper training, even further. Its semi-automatic operation allowed a faster rate of fire, improving squad-level effectiveness and enabling U.S. infantry to maintain suppressive fire during assaults. The rifle's design also incorporated the famous N-block clip, which held 8 rounds and automatically ejected after the last round was fired, producing the distinctive ping sound that became synonymous with the Garand in combat. While this sound sometimes alerted the enemy that a soldier was empty, it also became a psychological hallmark for American troops, symbolizing readiness and relentless firepower. The M1 Garand proved its worth in every theater of World War II. From the beaches of Normandy to the jungles of the Pacific, it gave soldiers a significant edge in infantry engagements. U.S. troops often reported that its semi-automatic capability allowed them to outfire opponents with bolt-action rifles, changing the dynamics of firefights and boosting morale. General Patton famously told Congress in 1941, "This rifle is the greatest battle implement ever devised." Beyond raw firepower, the Garand's reliability was legendary. Built to withstand the harsh conditions of combat, mud, sand, rain, and extreme temperatures, it rarely jammed when properly maintained. Its ruggedness made it trustworthy in the hands of both seasoned soldiers and fresh recruits, allowing American forces to maintain consistent firepower across long campaigns. Industrial production of the M1 Garand was another testament to American ingenuity. Over 5 million rifles were manufactured during World War II, thanks to the efficient mass production techniques pioneered by U.S. factories. This massive output ensured that American soldiers were consistently equipped with a weapon that was technologically superior, reliable, and deadly in combat. The impact of the M1 Garand extended beyond technical advantages. It shaped infantry tactics, allowing squads to coordinate faster, deliver continuous fire, and advance against fortified positions more effectively. It became a cornerstone of U.S. military doctrine, proving that a combination of innovation, training, and industrial capacity could produce decisive results on the battlefield. After the war, the M1 Garand continued to influence rifle design worldwide. Its semi-automatic mechanism, ergonomics, and durability set new standards for military rifles, inspiring future generations of infantry weapons. It was not only a tool of war but a symbol of American engineering and industrial power, demonstrating how superior design could give soldiers a critical edge. In short, the M1 Garand was far more than a rifle. It was the weapon that armed a nation, empowered its soldiers, and helped secure victory across multiple continents. Its legacy endures as a benchmark of reliability, innovation, and battlefield effectiveness, forever remembered as the rifle that gave American infantrymen the advantage they needed to fight and win. M4 Sherman, the backbone of Allied armor. In the vast battlefields of World War II, From the deserts of North Africa to the hedgerows of Normandy, one tank became synonymous with American and Allied armored strength: the M4 Sherman. While it was not the heaviest or most heavily armed tank of the war, the Sherman's reliability, versatility, and sheer numbers made it a cornerstone of Allied victories. It wasn't just a tank, it was a symbol of industrial power meeting battlefield necessity. Developed in 1941, the M4 Sherman was designed to replace older medium tanks and provide a balance of firepower, armor, and mobility. Equipped with a 75mm gun in most early models, later upgraded variants featured 76mm and even 105mm howitzer versions to adapt to changing combat conditions. Weighing around 30 tons, the Sherman could reach speeds of up to 30 miles per hour, allowing it to maneuver effectively across diverse terrains, from open plains to rough European forests. What truly set the Sherman apart was its production strategy. Unlike German tanks, which were often intricate, expensive, and slow to produce, the Sherman was simple to manufacture, maintain, and repair. Over 49,000 units were built during the war, with thousands shipped to Britain, the Soviet Union, and other allies under the Lend-Lease program. This massive output ensured that the Allies could field armored divisions in overwhelming numbers, even when individual Shermans were outgunned by heavier enemy tanks like the Tiger I or Panther. On the battlefield, the Sherman's effectiveness came from numbers and teamwork rather than raw superiority. In engagements, coordinated attacks with infantry, artillery, and air support allowed Sherman units to outmaneuver and outfight German armor. In North Africa, its mobility and adaptability helped defeat Rommel's forces. In Italy and Normandy, Shermans rolled through fortified positions, supporting infantry advances and helping secure key objectives. The Sherman was also highly versatile, with specialized variants designed for unique battlefield roles. Flamethrower Shermans, mine-clearing versions, and amphibious DD Shermans capable of crossing rivers and landing beaches expanded the tank's utility far beyond standard combat. Its adaptability made it invaluable across multiple theaters and missions, showing that a tank's worth is measured not just by firepower but by flexibility and survivability. Crew survivability was another strength of the Sherman. While German heavy tanks could often destroy it in a single hit, the Sherman's reliable engine and relatively simple mechanics allowed damaged tanks to be repaired and returned to service quickly. This meant that American armored divisions could sustain operations over long campaigns without catastrophic attrition, a factor that heavily favored the Allies in prolonged battles. Psychologically, the Sherman became a symbol of Allied determination. For soldiers on the front lines, seeing columns of Shermans advancing meant support, firepower, and protection. Its presence bolstered morale and enabled infantry to move forward with confidence, knowing that they had a dependable armored companion. Moreover, the Sherman's influence extended beyond the war. It shaped tank warfare doctrine, emphasizing combined arms tactics, mass production, and adaptability over the pursuit of perfect, technologically superior machines. The lessons learned from operating, coordinating, and improving Sherman units informed post-war armored vehicle development and military strategy worldwide. In conclusion, the M4 Sherman was far more than just a tank. It was the backbone of Allied armored forces, a reliable and versatile war machine that leveraged industrial might, tactical ingenuity, and adaptability to dominate battlefields. Its legacy is not measured merely in destroyed enemy tanks or miles advanced, but in its role as a symbol of Allied resilience and ingenuity, proving that reliability, strategy, and numbers often outweigh sheer technological superiority. P-51 Mustang, long-range escort fighter. As Allied bombers began striking deep into German territory during World War II, they faced a deadly vulnerability: no fighter could escort them all the way to their targets and back. Bombers like the B-17 Flying Fortress and B-24 Liberator suffered heavy losses to Luftwaffe fighters, threatening the effectiveness of strategic bombing campaigns. The solution came in the form of the North American P-51 Mustang, a long-range fighter that would become one of the most iconic aircraft of the war and a decisive factor in gaining air superiority over Europe. The P-51 Mustang was originally designed in 1940 for the British, but it became legendary when fitted with the Rolls-Royce Merlin engine. This engine upgrade gave the Mustang outstanding high-altitude performance, exceptional speed and agility, making it capable of engaging enemy fighters effectively at all altitudes. With a top speed of approximately 440 miles per hour and a combat range of over 1,600 miles with drop tanks, the P-51 could escort bombers from England to deep within Germany, ensuring their safety during crucial missions. Its armament was formidable. Most P-51s carried 6.50 caliber M2 Browning machine guns, allowing pilots to inflict serious damage on enemy aircraft. Later models could also carry bombs and rockets, enabling ground attack missions. This combination of speed, maneuverability, and firepower made the Mustang a versatile and lethal tool in the Allied arsenal. The P-51's impact on the European theater was profound. Before its arrival, Allied bombers were highly vulnerable once they crossed into German airspace. Luftwaffe fighters could inflict catastrophic losses, slowing the Allied strategic bombing campaign. With the P-51 providing continuous escort, bomber formations could penetrate deep into Germany with significantly reduced losses, striking critical industrial targets and crippling the Nazi war machine. By mid-1944, the Mustang had become the guardian of the skies, turning the tide in the air war over Europe. The Mustang was also flown by exceptional pilots, including members of the famed Tuskegee Airmen, the first African-American fighter pilots in U.S. military history. These pilots earned widespread recognition for their skill, courage, and effectiveness in combat, further cementing the P-51's legendary status. Its combination of technology and training made it a formidable match for any Luftwaffe aircraft, from the Focke-Wulf FW-190 to the Messerschmitt Bf-109. Production and deployment of the P-51 were remarkable. Over 15,000 units were built during the war, ensuring that the Allies could maintain air superiority in multiple theaters. Its long-range, reliability, and performance meant it could not only escort bombers but also carry out ground attack missions, strafing supply lines, airfields, and transportation networks, further weakening German war efforts. The P-51 Mustang's influence extended beyond combat. It boosted morale among bomber crews, who could now rely on protective escorts for the first time. It also demonstrated the strategic importance of long-range fighters in modern warfare, shaping post-war air combat doctrine and influencing the development of future fighter aircraft. In essence, the P-51 Mustang was more than a fighter plane. It was a game-changer, a technological marvel that combined speed, firepower, and endurance in a way that redefined air warfare. Its presence over Europe ensured the success of bombing campaigns, hastened the collapse of Nazi Germany, and solidified the Allied hold on the skies. The legacy of the P-51 Mustang endures as a symbol of American innovation, industrial capability, and battlefield effectiveness. It was the fighter that gave bombers the protection they desperately needed, the tool that allowed pilots to dominate enemy skies, and the aircraft that helped secure Allied victory in World War II. B-17 Flying Fortress, strategic bomber of the skies. When the United States entered World War II, strategic bombing quickly became a cornerstone of Allied strategy. To carry out this mission, the U.S. needed a bomber that could fly long distances, carry heavy bomb loads, and survive enemy defenses. That aircraft was the Boeing B-17 Flying Fortress, a machine that would become an enduring symbol of American air power and resolve during the war. The B-17 first took flight in 1935 and was designed to deliver high-altitude precision bombing. With a wingspan of 103 feet and powered by 4 Wright R-1820 radial engines, the B-17 could carry up to 8,000 pounds of bombs on short missions and over 4,500 pounds for longer operations. Its maximum speed of around 287 miles per hour and service ceiling of 35,600 feet allowed it to operate above many anti-aircraft guns and enemy fighters, although missions remained perilous. One of the most distinctive features of the B-17 was its defensive armament. Equipped with up to 13.50 caliber machine guns positioned in multiple turrets and nose, tail, and waist stations, it was designed to fend off Luftwaffe fighters without the need for fighter escort. This led to the nickname Flying Fortress, as it could sustain heavy attacks while still completing its bombing runs. Many aircraft returned to base with severe battle damage, proving the robustness of the design and the courage of the crews. The B-17 became the backbone of the U.S. 8th Air Force in the European theater, flying countless missions over Nazi-occupied Europe. Crews faced anti-aircraft artillery, flak, enemy fighters, and harsh weather, yet they continued to press their attacks against factories, railways, and strategic infrastructure. One mission over Schweinfurt in 1943, targeting ball-bearing factories, illustrated both the danger and determination of B-17 crews. Heavy losses were suffered, but the bombing significantly disrupted German war production. Precision bombing was a critical advantage of the B-17. Its design emphasized accuracy at high altitudes, enabling strikes on key industrial and military targets. Bombing tactics evolved throughout the war, including the famous combat box formation, which maximized defensive firepower while maintaining effective bombing patterns. These formations allowed B-17 units to inflict substantial damage while increasing survivability, demonstrating the synergy of technology and strategy. The B-17's impact went beyond its bombs. It became a symbol of American industrial might and morale. Thousands of aircraft were produced, with over 12,700 B-17s built during the war. Its iconic silhouette and steadfast reputation inspired both the crews who flew them and the civilians who watched them take off for perilous missions over Europe. Hollywood, newsreels, and wartime propaganda immortalized the Flying Fortress as an emblem of courage and technological achievement. The durability and effectiveness of the B-17 influenced the design of future bombers and strategic air doctrine. It proved that high-altitude, heavily armed bombers could play a decisive role in modern warfare, shaping the U.S. Air Force's approach to strategic bombing for decades to come. Its lessons informed aircraft like the B-29 Superfortress and later long-range jet bombers, bridging World War II innovation with post-war air power development. In conclusion, the B-17 Flying Fortress was more than a bomber. It was a weapon of strategy, a tool of industrial power, and a symbol of unyielding determination. Its long-range capabilities, heavy defensive armament, and resilience under fire made it indispensable to the Allied war effort. The Flying Fortress carried the weight of American strategy across Europe, striking deep into enemy territory and proving that courage, precision, and engineering could combine to turn the tide of war. B-29 Superfortress, the atomic age bomber. As World War II progressed in the Pacific, the United States faced the enormous challenge of striking the Japanese home islands from bases hundreds of miles away. Conventional bombers lacked the range, payload, and survivability needed to carry out these missions effectively. The solution was the Boeing B-29 Superfortress, a technological marvel that represented the pinnacle of American aviation engineering during the war and would ultimately play a decisive role in ending the conflict. The B-29 was introduced in 1944 and was the most advanced bomber of its time. It featured a pressurized cabin, allowing crews to operate comfortably at high altitudes, and remote-controlled gun turrets that could defend against attacking fighters. Powered by 4 Wright R-3350 radial engines, the aircraft could fly at speeds up to 357 miles per hour with a range of 3,000 miles, enabling long-range strategic missions across the vast Pacific theater. Its wingspan of 141 feet and maximum bomb load of up to 20,000 pounds made it a formidable presence in the sky. One of the B-29's most significant contributions was its ability to conduct precision bombing at unprecedented distances. It allowed the U.S. Army Air Forces to carry out sustained raids on industrial, military, and urban targets deep within Japan, disrupting supply lines, crippling production facilities, and undermining morale. Its high-altitude capabilities, combined with advanced radar and bombing technology, made it far more effective than earlier heavy bombers. The B-29 became infamous for its role in deploying atomic bombs, ushering in a new era of warfare. On August 6 and 9, 1945, 2 B-29s, Enola Gay and Boxcar, dropped atomic bombs on Hiroshima and Nagasaki. These missions demonstrated the bomber's long-range precision and payload capacity while bringing about the end of World War II in the Pacific. The B-29 had effectively changed the course of history, combining technological innovation with strategic impact. Beyond the atomic missions, B-29s conducted extensive firebombing raids over Japanese cities, including Tokyo, which caused significant destruction to urban areas and industrial infrastructure. These raids forced Japan to divert resources to homeland defense and contributed to the overall weakening of Japanese resistance. The aircraft's versatility, capable of both strategic bombing and tactical support, made it a cornerstone of U.S. air operations in the Pacific. Production of the B-29 was a massive undertaking. Over 3,900 aircraft were built, reflecting the industrial might of the United States. Its complexity required significant innovation in assembly line production, engine reliability, and electronic systems. Despite initial challenges with engine overheating and mechanical reliability, the B-29 eventually became a dependable and highly effective weapon, symbolizing the combination of American ingenuity and industrial capacity. The B-29 also influenced post-war aviation. Its design innovations, from pressurized cabins to remote gun turrets and long-range performance, laid the groundwork for modern strategic bombers and advanced military aviation technology. It demonstrated the importance of combining speed, range, firepower, and technology in aircraft design, lessons that would shape the Cold War era of air power. In conclusion, the B-29 Superfortress was more than a bomber. It was a revolutionary weapon of strategy, innovation, and power. Its long-range, advanced systems, and immense payload capability allowed the United States to project air power across the Pacific, devastate enemy infrastructure, and ultimately force Japan's surrender. The B-29 symbolized the atomic age, American industrial might, and technological superiority, proving that engineering excellence combined with strategic vision could decisively shape the outcome of war. Jeep Willis MB, the vehicle that moved armies. When American troops landed on the beaches of Normandy, patrolled the deserts of North Africa, or advanced through the jungles of the Pacific, one vehicle became their most trusted companion, the Jeep Willis MB. Though small and unarmored, this humble four-wheel drive vehicle embodied versatility, reliability, and ingenuity, earning its place as one of the most iconic vehicles of World War II. The Jeep was developed in 1941 in response to a U.S. Army request for a lightweight, durable, and all-terrain reconnaissance and utility vehicle. Willis Overland and Ford produced competing prototypes, but the Willis MB emerged as the standard, equipped with a 60-horsepower engine, capable of speeds up to 65 miles per hour, and able to carry up to 800 pounds of cargo or a small squad of soldiers. Its short wheelbase, high ground clearance, and four-wheel drive allowed it to traverse mud, sand, snow, and rugged terrain with ease, something larger trucks or armored vehicles could not accomplish. The Jeep's design emphasized simplicity and ruggedness. Its lightweight frame and minimal components made it easy to repair in the field, often by soldiers themselves. This meant that even in harsh conditions, the Jeep could continue to operate when other vehicles failed. Its versatility allowed it to perform a wide range of roles: reconnaissance, command transport, ambulance, artillery towing, and even light weapons platform when fitted with machine guns. In the European theater, the Jeep was a force multiplier. It transported officers and soldiers across the front lines, delivered supplies to advancing units, and performed reconnaissance missions to gather intelligence on enemy positions. In North Africa and Italy, it conquered deserts and mountain passes, proving that mobility and adaptability could be as crucial as firepower. In the Pacific, the Jeep maneuvered through jungles, muddy trails, and island terrain, often carrying troops where larger vehicles could not go. Production of the Jeep was remarkable. Over 640,000 units were built during World War II by Willis and Ford combined. Its ease of production and maintenance meant that virtually every unit in the field had access to this dependable vehicle. It became a symbol of American ingenuity and mass production capability, reflecting the ability of U.S. industry to equip its forces with tools that were both practical and reliable. The psychological impact of the Jeep should not be underestimated. Soldiers often described it as life-saving, dependable, and morale-boosting, providing a sense of mobility and independence on the battlefield. Its ability to reach remote areas, evacuate wounded soldiers, or quickly transport ammunition and communications personnel made it an essential lifeline in combat operations. Even after World War II, the Jeep's legacy endured. Its design influenced countless military and civilian vehicles, shaping the concept of the light, four-wheel drive utility vehicle. The post-war civilian Jeep became a cultural icon, but its wartime reputation as a rugged, indispensable military vehicle remains unmatched. In essence, the Jeep Willis MB was not the most powerful or heavily armed vehicle of World War II, but it was arguably the most versatile and indispensable. It moved armies, carried supplies, saved lives, and enabled mobility in ways that tanks and trucks could not. It was the small but mighty machine that allowed soldiers to navigate the chaos of battle with confidence, proving that sometimes, the right tool in the right hands is more valuable than sheer firepower. Bazooka, the portable anti-tank weapon. On the battlefields of World War II, infantry needed a way to stop tanks without calling down artillery or hoping for friendly armor to arrive. The answer came in a simple, terrifying package: the bazooka, a shoulder-fired, rocket-propelled anti-tank weapon that handed ordinary soldiers the power to destroy armored vehicles at relatively close range. The bazooka emerged from urgent battlefield demands and rapid wartime innovation. Early in the war, infantry units were dangerously exposed to armored attacks. Handheld anti-tank rifles were heavy and rapidly becoming ineffective, and anti-tank guns were bulky and not always where they were needed. Engineers developed the bazooka as a light, man-portable launcher that fired a shaped-charge rocket warhead. Fired from the shoulder, it allowed small teams to ambush tanks, hit vulnerable flanks or rears, and deny enemy armor freedom of movement. Its operational simplicity was part of its brilliance. A typical bazooka crew consisted of 2 men, a gunner and a loader/assistant. The launcher itself was an open tube that held the rocket. Ignition came from an electrical firing system. The backblast and signature of the rocket were immediate, so crews had to shoot from cover and relocate quickly. Reloads were fairly rapid for the period, and with proper tactics, concealment, teamwork and targeting, bazooka teams could punch far above their weight. The weapon's warhead used the shape charge or heat, high-explosive anti-tank principle, a cone of metal that, when detonated, focused explosive energy into a jet capable of piercing armor. That meant the bazooka didn't rely on kinetic force or projectile mass. It relied on focused explosive energy, allowing a relatively small warhead to defeat much thicker armor than one might expect for a handheld weapon. In early and mid-war, this made the bazooka especially effective against the lighter armor common on many tanks and armored vehicles. First widely used by American forces in the early 1940s, the bazooka saw action across every theater, from the hedgerows of Normandy to the bocage of Italy and the islands of the Pacific. It changed infantry anti-tank tactics. Platoons and squads no longer had to wait for dedicated anti-tank guns. They could form small mobile teams capable of hunting tanks in ambush, in urban rubble, or in close country where tanks were most vulnerable. Paratroopers and other light forces prized the bazooka because it was transportable, quick to bring to bear, and capable of giving them a fighting chance against heavier enemy armor. The psychological effect was significant. Tank crews, used to dominating infantry, now had to fear delayed or hidden threats at flank or rear. On several occasions, a few well-placed bazooka shots stopped armored advances or forced risky route changes. The weapon's presence forced armored commanders to adjust tactics, more infantry screens, closer coordination with reconnaissance, and efforts to keep tanks moving rather than presenting static targets. Like every weapon, the bazooka had limitations. Early models were more effective against early war tanks than against later heavy designs with thicker frontal armor. The shooter had to approach to effective range, often a few dozen meters to a few hundred meters depending on model and conditions, which could be hazardous. Backblast revealed firing positions, and poor crew training or improper aim reduced effectiveness. Armor improvements and battlefield countermeasures, sloped armor, spaced plates, and added applique, diminished some of its stopping power against the heaviest tanks. But in practice, even when it could not defeat frontal armor, the bazooka was deadly against tracks, fuel tanks, engine compartments, or side/rear armor. The weapon also inspired further anti-tank development. Allied and Axis forces alike accelerated production of infantry anti-armor weapons and tactics, from bullet-firing anti-tank rifles and recoilless rifles to British designs like the PIAT and post-war systems that evolved into the family of rocket-propelled grenades, RPGs, used around the world. The bazooka's principle, empowering infantry with a portable shaped charge launcher, influenced decades of weapons design. Beyond technical impact, the bazooka embodied a broader shift in warfare, industrial innovation coupled with pragmatic battlefield adaptation. It was mass-produced, simple to maintain in the field, and issued widely so squads everywhere could carry anti-armor capability. That democratization of destructive power altered operational planning and gave infantry commanders new options on how to fight and survive against mechanized forces. In short, the bazooka turned the balance between infantry and armor. It did not make tanks obsolete, but it ensured that tanks could not operate unchallenged by regular soldiers. Light, mobile, and lethal in the right hands, the bazooka was a game-changer. A small weapon with outsized consequences that helped Allied infantry survive, fight back, and win in countless engagements across World War II. M1919 Browning machine gun, the soldier's reliable firepower. If World War II had a soundtrack for steady, disciplined fire, the M1919 Browning would be a major part of it. Designed by John Browning and refined through decades of service, the M1919 was the United States standard medium machine gun in World War II, a dependable belt-fed workhorse that gave American infantry, vehicle crews, and defensive positions sustained, accurate fire when it mattered most. The M1919 was chambered for the ubiquitous .3006 Springfield cartridge, the same round used in rifles across the U.S. forces. That commonality simplified logistics. The same ammunition that fed rifles also fed many Browning guns. The basic configuration that saw the most service was the M1919A4, an air-cooled belt-fed weapon that balanced durability with relative portability. The gun itself weighed in at roughly 30 to 32 pounds. Mounted on the popular tripod or installed on vehicles with pintle mounts, it became an adaptable element of American firepower. What made the M1919 invaluable was less dramatic than a single spectacular shot and more about sustained performance. Its cyclic rate of fire, typically around 400 to 600 rounds per minute depending on model and condition, allowed crews to lay down effective suppressive fire without the extreme barrel wear and overheating of some lighter automatic weapons. On a tripod with proper fire discipline, the M1919 could engage area targets out to 1,500 to 1,800 yards, and deliver accurate, point-target fire at several hundred yards. In short, it combined reach and controllability in a way that matched combined arms doctrine. Infantry advances supported by overlapping machine gun belts, defensive sectors sealed with interlocking fields of fire. Versatility was another hallmark. The M1919 served as a company-level support weapon, normally operated by a crew that included a gunner, assistant gunner, and ammunition bearers. It was also widely adapted for vehicle use, mounted on jeeps, armored cars, half-tracks, and tanks, where it functioned as a coaxial or anti-infantry weapon. Aircraft versions and derivatives existed earlier in the century, but the ground roll M1919 was the ubiquitous backbone of American small-unit firepower. Field conversions and local modifications were common. Crews would fit barrels, heat shields, and improvised mounts to suit mission needs, a testament to the gun's practical design. The M1919's reliability in varied climates was a major advantage. It operated effectively in North African heat, European mud, and Pacific humidity, provided crews kept it reasonably clean and supplied. Compared to more delicate automatic weapons, the Browning's relatively simple, robust components tolerated the grit and grime of frontline service. Spare parts were standardized and widely available across U.S. logistical networks, and training emphasized basic maintenance, strip, clean, and reassemble, making it a weapon that small units could keep running under pressure. Tactically, the M1919 reshaped engagements. Where previously a platoon might rely on mortars or artillery for sustained fire, the Browning allowed organic, immediate support, pin down an enemy squad, suppress a machine gun nest, or cover a withdrawal. During assaults and defenses alike, properly sighted M1919s could dominate avenues of approach, control crossroads, and protect flanks. In urban fights and bocage country, their rapid, accurate bursts created kill zones that forced enemy movement into predictable channels. No weapon is without limits. The M1919 was heavier and less maneuverable than light machine guns. It required a crew to operate at peak efficiency and depended on a steady supply of ammunition. Belts of 250 rounds were common, but sustained firing consumed material quickly. Barrel changes were necessary under intense fire, and the gun's weight made rapid infantry maneuvers more challenging. Against heavily armored targets, the .3006 round could not substitute for dedicated anti-tank weapons. Yet these limitations were predictable and manageable. Commanders planned around them. The M1919's legacy stretched beyond World War II. Variants continued to serve in Korea and into the early Cold War era, and its influence on automatic weapons doctrine was profound. It demonstrated how reliable medium machine gun fire, when integrated into formations, could multiply combat power far more effectively than isolated small arms alone. The Browning family, in various calibers and forms, has influenced weapon design ever since. In the end, the M1919 was not glamorous. It did not promise a single decisive strike. What it did provide, repeatedly and dependably, was the relentless, controlled fire that allowed American troops to move, hold, and win. For countless soldiers across deserts, forests, and islands, the M1919 was the dependable presence that turned tactical plans into battlefield reality, the soldier's reliable firepower. Landing craft, vehicle, personnel, LCVP, the amphibious warhorse. When Allied forces planned the largest amphibious invasions of World War II, from North Africa to Normandy, success depended not just on tanks and planes, but on the humble, yet indispensable landing craft, vehicle, personnel, LCVP. Commonly known as the Higgins boat, this small amphibious vessel became the unsung hero of beach assaults, carrying troops, vehicles, and supplies from ship to shore under enemy fire. Designed by Andrew Higgins, a Louisiana boat builder, the LCVP addressed a critical problem: how to transport men and equipment from larger ships to beaches that often lacked proper docks or piers. Traditional naval vessels could not approach shallow, fortified shores, leaving troops vulnerable to enemy fire during disembarkation. Higgins' design featured a flat-bottomed hull, a bow ramp, and a shallow draft, enabling the boat to run directly onto beaches, lower its ramp, and deploy troops and equipment quickly. The standard LCVP could carry 36 fully equipped soldiers, a jeep, or a small artillery piece, with a payload of roughly 8,000 pounds. Powered by a Hercules 6-cylinder gasoline engine, it reached speeds of 12 knots, fast enough to make repeated trips between transport ships and the shore. Its rugged steel hull could withstand rough surf and minor enemy fire, while the ramp allowed troops to exit quickly and deploy directly into combat. The LCVP proved decisive in almost every amphibious assault conducted by Allied forces. In the D-Day landings at Normandy, thousands of Higgins boats delivered infantry, tanks, and supplies to beaches under heavy German fire. Their speed and efficiency allowed for rapid buildup of combat power on the shore, turning an incredibly vulnerable landing into a sustained and ultimately successful assault. The flexibility of the LCVP also allowed them to operate in diverse theaters, from the beaches of North Africa to the islands of the Pacific, supporting both U.S. Army and Marine operations. The craft's impact extended beyond simply transporting troops. It allowed commanders to coordinate combined arms assaults, moving infantry and armor together in a synchronized manner. It could carry wounded soldiers back to larger ships for medical care, support supply lines, and serve as a mobile platform for reconnaissance or communications. In essence, the LCVP multiplied the effectiveness of amphibious forces, giving them mobility and adaptability that was unmatched by other craft of the era. Over 20,000 LCVPs were produced during the war, a testament to their vital role and the American industrial capability to mass-produce a craft that was both simple and highly effective. The design simplicity made it easy to build, maintain, and repair under combat conditions. Even unskilled personnel could operate and unload the craft efficiently, which was crucial during high-intensity assaults where seconds could determine life or death. The psychological effect of the LCVP should not be underestimated. For soldiers storming beaches under enemy fire, The sight of multiple Higgins boats delivering waves of reinforcements provided a sense of momentum and hope. For defenders, these boats represented the unstoppable tide of Allied forces, capable of breaching the most fortified coastal positions. Their presence changed the dynamics of amphibious warfare, demonstrating that logistics and mobility were just as decisive as firepower. Post-war, the LCVP's legacy influenced modern amphibious warfare. Its design principles, shallow draft, ramp for rapid deployment, and robust construction, became the foundation for landing craft used by navies around the world. The Higgins boat proved that innovation, practicality, and mass production could shape the outcome of entire campaigns. In summary, the Landing Craft Vehicle Personnel, LCVP, was a critical enabler of Allied victories. Small, simple, and rugged, it allowed soldiers, vehicles, and supplies to reach hostile shores, directly impacting battles from North Africa to Normandy and the Pacific Islands. Without the Higgins boat, many amphibious operations would have faltered, and the tide of World War II might have been very different. It was not just a vessel, it was the amphibious warhorse that carried victory from ship to shore. Atomic bomb, Little Boy and Fat Man, the ultimate weapon that ended the war. By the summer of 1945, the Second World War had already consumed continents, economies, and countless lives. Yet the fighting in the Pacific showed no sign of a quick end. Japanese forces continued to resist fiercely from islands, cities, and entrenched positions, and Allied planners anticipated staggering casualties in any planned invasion of the home islands. Into that brutal calculus stepped a new terrible instrument of power, the atomic bomb, a weapon born of the Manhattan Project that would change war and history itself. The Manhattan Project was the largest scientific and industrial undertaking of its era. Under the direction of Army General Leslie R. Groves and scientific leadership from J. Robert Oppenheimer, thousands of scientists, technicians, and workers at sites from Los Alamos to Oak Ridge and Hanford raced to unlock the energy bound within the atom. By mid-1945 they had succeeded. Two fundamentally different designs were ready for use. One was a uranium gun device, codenamed Little Boy. The other was a plutonium implosion device, Fat Man. On August 6, 1945, a B-29 superfortress named Enola Gay carried Little Boy over the city of Hiroshima. The bomb detonated at an altitude of roughly 1,900 feet, releasing an explosion equivalent to about 15 kilotons of TNT. The blast obliterated buildings across miles, generated searing heat that ignited fires, and produced a shockwave that leveled neighborhoods. Tens of thousands died instantly. Hospitals, communication networks, and firefighting capabilities were destroyed. Survivors faced terrible burns, traumatic injuries, and the long poorly understood effects of ionizing radiation. 3 days later, on August 9th, a second B-29 boxcar dropped Fat Man on Nagasaki. Fat Man's implosion design produced an even larger blast, roughly 21 kilotons, and though the topography of Nagasaki reduced its area of destruction relative to Hiroshima, the human toll was immense. Estimates of immediate and later deaths vary, but by the end of 1945 casualties in Hiroshima numbered in the tens of thousands to over 100,000. Nagasaki's death toll was similarly catastrophic. Beyond the immediate carnage, survivors faced radiation sickness, long-term cancer risks, and social devastation that would last generations. The military and political rationale for using the bombs was straightforward in Allied planning. American leaders faced the prospect of a costly invasion of Japan, projected to inflict extremely high casualties on both Allied forces and Japanese defenders. Proponents argued that the shock and destruction produced by the atomic strikes would compel Japan to surrender without a ground invasion, shortening the war and saving lives overall. President Harry S. Truman, after receiving reports on the new weapon and weighing alternatives, authorized use against military targets in Japan. The immediate strategic effect was decisive. The combined shock of the two detonations, the Soviet Union's declaration of war on Japan on August 8, and the implosion of Japanese command cohesion produced rapid political movement in Tokyo. On August 15, 1945, Emperor Hirohito announced Japan's acceptance of unconditional surrender. The formal surrender ceremony followed on September 2, 1945. The bombs had not only razed cities, they had altered the political calculations that kept Japan fighting. Yet the atomic bomb's legacy is double-edged and complex. Technically, it demonstrated the terrifying efficiency of nuclear fission as a weapon. Strategically, it ended the bloodiest conflict in human history. Morally and politically, it opened profound debates that continue today. The human cost was immense and immediate. Tens of thousands of civilians killed outright, many more injured, and countless lives shortened or scarred by radiation. Ethicists, historians, and veterans have argued about necessity, alternatives, and the long-term consequences ever since. Scientifically, the project's personnel and the captured German and Japanese research that followed seeded post-war nuclear and space programs worldwide. Engineers and scientists who once built weapons of war later became architects of peacetime technologies, and in other cases, of nuclear arsenals that dominated the Cold War. The technical breakthroughs, metallurgy, rocketry, reactor engineering, and precision guidance, reshaped the post-war world in ways the Manhattan Project's planners scarcely imagined. In the narrative of World War II, the atomic bombs stand as the final decisive instruments that ended the global conflagration. They were born of massive industrial mobilization and cutting-edge science, and delivered through airframes like the B-29S that had come to symbolize American air power. They resolved an immediate strategic problem: how to force Japan's surrender without a bloody invasion. But they also introduced the planet to a new era, one in which the capacity to destroy cities instantly would reshape geopolitics, ethics, and human imagination. The atomic bombs of Hiroshima and Nagasaki were the ultimate weapons of World War II, instruments that ended the war, saved certain projected battlefield lives, and simultaneously inaugurated a fraught new chapter in human history, where the power to obliterate civilization existed alongside the hope that such power would never again be used.